Good day, students. Now consider a new topic named the investigation of the given function for convexity, concavity, and inflection points with help of the second, third, and higher derivatives. Now write our topic, the name of our topic, the investigation of function, of the given function for convexity, concavity, and inflection points. First, give the indications of convexity concavity intervals. If second derivative is positive, then our function is convex down or concave up. Convex down or concave up. That is, the graph of such a function has the following form: convex down and concave up. Convex in Azeri it is kabarık, convex down aşağı kabarık. In Russian выпуклый вниз. Concave is çökük. Concave up yukarı çökük. In Russian it is вогнутый. Concave up, вогнутый вверх. It is the configuration of the graphs whose second derivative is positive. But if the second derivative is negative, then the graph of such a function has the following form. And here we have that this function is convex up, or concave down. Then give the definition of the inflection point. Inflection point is such a point at which the convexity, the concavity of the given function changed on direction. And for finding of the inflection point, first we must know the second order critical points. For the obtaining the second order critical point, we must equalize the second derivative to 0. That is, give the definition of the second order critical points, right? Second order critical points are such are such points at which the second derivative second derivative is zero or doesn't exist. Then continue. Then consider the sufficient conditions for the inflection point's existence. The sufficient conditions for the inflection point existence. Here, first find the second order critical point. Then the obtained second order critical points mark in the real axis, and divide whole real axis into intervals by these second order critical points, and then find the signs of the second derivative in each interval. If in the passing through the given critical point of second order from the left to the right, the sign of the second derivative is changed, then it means the second order critical point is also the inflection point. But if the sign of the second derivative is not changed, then it means the given second order critical point isn't inflection point. Right. First point. If the sign of second derivative, the sign of the second derivative is changed, then the given second order critical point, is the inflection point. Inflection point in Hazar it is eğilme noktası, eğilme, and in Russian it is перегиб, точка перегиба, перегиб. It's changed. But if the sign of the second derivative is not changed, then isn't inflection point. Isn't inflection point. inflection point. That is, if the sign of the second derivative isn't changed in the passing through the given critical point of second order, then it means the given second order critical point isn't inflection point. Now go to the examples. Go to the first. Go to the fourth Roman point, named the investigation of the given function for convexity-concavity intervals and the inflection points with help of the second derivative. Remember that in the first Roman point we found the increase-decrease intervals and extremum points with help of the first derivative. In the second Roman point we found the extreme points with help of the second derivative. And in the third Roman point we found the extreme points with help of the high derivative. Now open the fourth Roman point, and in this point we will find the convexity-concavity intervals and the inflection points. The investigation the given function, investigation the given function for convexity-concavity and inflection points with help of the second derivative, with help of the second derivative. Now give the concrete function. Our function is f of x to 6 minus 3x to 5 minus 20x to 4 plus 50x and plus 40. Solution. First, we must find the second order critical points. It means we must equalize the second derivative to 0 and then find the roots of the obtained equation. For finding the second derivative, first we must find the first derivative. First derivative is f prime of x. X is 6x to 5 minus 15x to 4 minus 8x cubed plus 50. F2 prime of x equals 30x to 4. You know that the second derivative is the derivative of the first derivative, minus 60x cubed minus 240x x squared, and equalizes to 0. We can, for solving this equation, we can take 30x squared out of the parenthesis. 30x squared multiplied by x squared minus 2x minus 8 is 0. And then we can find the roots of this equation. First root is 0. Second root is minus 2, and third root is 4. Are the second order critical points. Second order critical points. Remember that the second order critical points, such points at which the second derivative is 0 or second derivative doesn't exist. Then construct a real axis or numeric axis, and mark the second order critical points in this axis, minus 2, 0 and 4. Minus infinity, plus infinity. Then separate the real axis into intervals by these points. And then define the signs of the second derivative in each interval. In the right interval we can take 10. Here you must take the interior comfortable points for each interval. For example, we can take here 10 and substitute 10 instead of this expression. Substitute 10 instead of x. 100 minus 20 is 80, minus 8, 72, it is positive. Then here we can take 2. It is always positive. 2, 4 minus 4, 0, minus 8 is minus. Here we can take minus 1. 1 plus 2, 3, 3 minus 8 is minus 5, also negative. And then we can take minus 10. 100 plus 20 is 120, minus 8 is 112, positive. And you know that the second derivative is positive, it means our function is convex down or concave up. Convex down or concave up. And if the second derivative is negative, then it means our function is convex up or concave down. Then look at these intervals. If pass through the point minus 2 from left to right, or in the passing through this given point, second derivative change own sign. It means this point is inflection point. Inflection. Here the sign of the second derivative isn't changed. It means this point isn't inflection point. No inflection. And here at this point, the sign of the second derivative is changed from minus to plus. It means this point is inflection point. Thus, we have following result. The interval from minus infinity to minus 2, we can write answer. For x belonging from minus infinity to minus 2, united with the interval from 4 to plus infinity, are the convex up. I'm sorry. Convex down are the convex down or concave up intervals. Then for x belonging from the minus 2 to 0, united with the interval from 0 to 4, these intervals, the union of these intervals are the convex up, or also concave down intervals. Then mark the inflection and non-inflection points. X equals minus 2 and x equals 4 are the inflection points. But x equals 0 isn't inflection point. It is our answer. Then go to the next Roman point, fifth Roman point. Investigating the given function, the given function for inflection points, for the inflection points, with help of the third derivative, with help of the third derivative. Here, first find the second order. Find the second order critical points. Then find the third derivative, and further calculate the value of third derivatives at the second order critical points. If the value of third derivative isn't equal to 0, it means the given second order critical point is the inflection point. But if the value of the third derivative at the second order critical point is 0, then we have the indeterminate case. Now write this rule. Write this rule. First ordinary point. If the value of third derivative at the second order critical point isn't equal to 0, then this critical point is the inflection point. Is equal to 0, then inflection point. But if the value of the third derivative at the second order critical point is equal to 0, then this critical point is an inflection point. Second order is equal to 0, then isn't inflection point. I'm sorry. Then we have the indeterminate case. Then we have indeterminate case. It means in this case the second order critical point can be inflection point and also cannot be the inflection point. Now consider the corresponding example. Now use again the previous example for the finding the inflection point with help of the third derivative. Example: find the inflection points of the given function with help of the third derivative. Inflection points. Now write the previous function, f of x equals x to 6 minus 3x to 5 minus 20x to 4 plus 50x plus 40. Solution. First find here second derivative and then equalize the second derivative to 0, but first find the first derivative, because the second derivative is the derivative of the first derivative. F prime of x equals 6x to 5 minus 15x to 4 minus 80x cubed plus 50. Then find derivative of the first derivative, and it is a second derivative, equals 30x to 4 minus 60x cubed minus 240x squared. Then equalize the second derivative to 0. For finding the roots of this equation, we can take 30x squared out of the parenthesis, the 30x squared multiplied x squared minus 2x minus 8 is 0. And then find the second order critical points. Second order critical points is the zeros of the second derivative. X first equals 0, x second is minus 2, and x third is 4. Are the second order critical points. Then find, calculate the find the third derivative, and you know that the third derivative is the derivative of the second derivative. Third derivative f 3 prime of x equals, and take the non-factorizing expression. It is 120x cubed, 120x cubed minus 180x squared, and here minus 480 x. Then we can take here 60x out of the parenthesis, 60x multiplied by 2x squared minus 3x minus 8. Then calculate the values of the third derivative at these second order critical points. Then continue. Then calculate the values of the third derivative at the second order critical points. f3 prime at 0, equals, substitute 0 instead of x in this expression. It is 0, and it means we don't know, it is a indeterminate case, that is, we don't know whether the given function has the inflection point or no at 0. It is we have the indeterminate indeterminate case. Indeterminate case. Then substitute the third derivative at -2. -2 equals, calculate, use the factorizing expression. It is -120 multiplied by, here we have 8, simply 8, plus 6 minus 8, and it is minus 720, and it isn't equal to 0. It means x equals -2 is the inflection point. Finally, calculate the third derivative at the point 4. F 3 prime at 4 equals, multiplied by 4 is 240 multiplied by, it is 16, 32 minus 12 and minus 8 equals 240 multiplied by 12, and it isn't to 0. It means x is 4 is also the inflection point. Thus, our given function has two inflection points. X is -2 and x is 4 are the inflection points, but 0 isn't inflection point. Finally, please rewrite your homework. The function is given, and find the convexity-concavity intervals and the inflection points with help of the second derivative. And second problem, find only the inflection points with help of the third derivative. Please rewrite. Our lesson ended. Dear students, good luck. Goodbye, students.